Okay, so this is a tutorial to get you started with the Sediments practical, and what I'm going to do is go through the computer practical that we did today, or if you're watching this later on, the 19th of October, and that will then give you the tools or the method to be able to do the Sediments exercise when you get the class data. Right, so let's go first of all to the Coastal Sediments Field Study site. There it is. And if we go to assignments, Sediments exercise, let's make this bigger, and then if you scroll down, you'll find under the title Particle Size Analysis Computer Practical 2 files. So one's an Excel spreadsheet that has three samples in it that represent 3 sieving sessions, and then the next file is a Sigma plot file which allows you to plot the data in the Excel spreadsheet so that you can have a look at the particle size distribution, and that will allow you to work out the percentiles, so D5, etc., to be able to work out mean size, sorting and skewness for each sample. So firstly we need to download these files. So if I click on the computer practical, I'm going to press on this arrow to show in folder. Okay, that's it there. So I'm going to right click it, copy, and then I'm going to save it in a new folder called Sed Exercise. Open that and then press paste. Got a copy of the Excel spreadsheet in there. And then I'm going to do the same with the Sigma plot file. Oops. Show in folder. Copy. And paste. Okay, so I've got the 2 files that I need in a sensible folder, so I know where they are. I'm going to close these. Now what we want to do is open up Sigma plot. Okay, now you may not get the file coming up here, so I'm going to do this the old-fashioned way. So if I go to the main button, go to open, and then I'm going to go to documents and find my Sed exercise folder, and if I double click that, this will open. So what you should end up getting is a data sheet which has the 5 values that correspond to the 5 values in your Excel spreadsheet, which also correspond to the sieve stacks used to sieve the samples. And then the next page is the graph. Okay, so this graph on the y-axis has the cumulative percentage coarser than, so that's what we calculate from the sieving practical. And note that it's plotted on a log axis, and then on the x-axis you have the phi grain size. So what I want to do now is populate that graph with the data from the sediment data in the Excel spreadsheet. So what I'm going to do first of all is create a new data sheet. So what I've done is I've gone into the notebook here, right clicked it, scroll down to new, and a new worksheet. So when you do that, get another data worksheet, and that's where I'm going to import the data from the Excel spreadsheet. I don't want to import it into this data sheet because it will corrupt the graph that we're creating. Okay, so if I've got the new data sheet here. Now if I go to worksheet at the top, import file, now this has directed me straight to my Sediments exercise folder, which is great, and then I can click on the Excel file that I've downloaded from Blackboard. Now the Excel file that I've given you has multiple sheets. So the first sheet is called All Data, which just gives you a summary of the 3 samples, and then the subsequent sheets are the raw data from the sieving. So I'm going to click on sample 1 first and import. So what I now have is the data from my Excel spreadsheet in Sigma plot, which I can now use to populate my graph to have a look at the particle size distribution. So I'm going to select up to 4 phi because that's the limit of our particle size distribution. The mass of our pan mass is just any part of the sediment that is smaller than our last sieve, which was 63 microns. So that's the clay and silt fraction of our sediment sample, which can't be included in this particle size distribution. So I'm going to do Control C, copy that data, and I'm going to go over to data 1 and Control V, paste that data into here. That's annoying. Right, anyway, so now we go to the graph page 1, and you should see that your graph has been populated with the data that you've put into the data worksheet 1. And what you can now do is work out or read off from the graph your 5th percentile, your 16th percentile, the 50th percentile, 84th percentile, and the 95th percentile. And they correspond to D5, D16, D50, D84 and D95 in the last data sheet of the Excel spreadsheet. So you have a line for each of these percentiles. You can ignore the 25th and the 75th percentile, we don't need those. So if you just put your cursor over where the line for the percentile that you're interested in intersects with the particle size distribution, you can then note down, so y equals 5. Now what I'm looking for is for you to just get 5.0 or 16.0 or or 50.0, and then note down the corresponding x value. Okay, so in this case it's 2.57 phi for the 5th percentile. This can be made slightly easier if you zoom in onto the graph. So you want to go ahead and do that for all the percentiles for this sample, and then you can do the same again for the other 2 samples. And when you do this for the sediments exercise for the actual assignment, you will be doing this for the data that you'll be provided with on Friday the 23rd of October. And so each time you just want to create a new data sheet, or worksheet, sorry, to correspond with each sample. Okay, and then what you should end up with is a table like this with values for each sample for each percentile. And then these values are what you're going to use in your MATLAB script to calculate the graphic mean, standard deviation or sorting, and skewness. I'm going to do a separate tutorial for that.